aquí tenéis al modelo.
Para esto quedaba ya.
Para esto quedaba, para hacer el modelo. Vale. Supone que ese es el modelo también. ¿Me mola? 10 euros. Se supone que ayudemos a pagar los Meetup. O sea, Meetup de eso. Sí, pero no está.
Test, test. Can you hear me? Can you hear me? Can you hear me? Yeah.
I will adjust the volume.
Esta pregunta me han puesto a veces cuando hago. ¿Cómo os habéis enterado que existía el grupo? ¿Sabéis que hay un grupo, hay un Twitter? ¿Sabéis que hay un grupo de Telegram? ¿Sabéis que hay una página web? ¿Sabéis que hay una lista de correos? ¿Sabéis que hay un grupo de Google Plus? ¿Qué más cosas sabéis? Perdón. El Meetup. Vale, por Meetup he llegado. Vale. Este está bien, vale. Pues nada. Que era eso. La página web en la que colgamos todas las charlas desde hace 4 o 5 años es madrid.devops.es, por si queréis ver el histórico, que hemos hablado de muchas cosas a lo largo de los años. Y ahora voy a empezar las charlas en inglés, por cierto. Si alguien quiere que Antón hable en español, que lo diga ahora, que hay para siempre. No se lo hemos dicho, o sea, pues ya, no sé. Ese día que te dejé tonterías. Son y 10 casi, o sea que yo creo que las 10 minutos de cortesía han terminado, ¿vale? Pues ya está. No sé, empiezo en español, empiezo en inglés. Igual, venga. Que buenas tardes. Este es el segundo meetup del mes de septiembre de Madrid Devops. Hace 15 días tuvimos uno sobre protocolos de Devops, que es un sistema distribuido de transferencia de acuerdos, vamos a decirlo así, entre procesos. Y estaremos editando el vídeo y saldrá cuando salga, ¿vale? Las slides no se están colgadas. La semana que viene, pero no metemos presión. No metemos presión. No. Y nada, esto es un poco. Es la primera vez que tenemos 2 charlas en el mismo mes. Sin red, Normalmente nos suelen faltar charlas. Si conocéis a alguien que le guste dar una charla que no quiera vender su producto, es decir, que filosofía open source, explicar cosas, ser abierto, etcétera, compartir, sois más que bienvenidos, difundir la idea de que queremos que la gente explique lo que hace y luego, después de las charlas, tomarnos algo y compartir lo que hacemos todos los días, etcétera. Y nada, yo creo que sin más dirección, ya voy a presentar a Antón, a Babenko. He is let's say, you're freelance, isn't it?
Yes.
Okay, let's say he's coming from Norway. He works every day with AWS and Terraform, and he's giving us a talk about Terraform. He's currently you're maintaining some modules.
I will explain what I do.
So
it's not just one sentence.
So please come here.
Okay. Hola, ¿qué tal? That's all. No, actually, yo aprendo español, pero inglés es muy Vasil. Okay, so today I'd like to get your attention about Terraform modules and a little bit more. So during my talk, I know that it may be not so easy for you, but feel free to interrupt me as soon as you start losing what I'm trying to tell you, because it may be very obvious for me, because I work with these things for many years, and it may be not so easy for some of you who don't know what I'm talking about. So today we'll talk about different things, like what is it, some introduction, and then we'll talk about frequent Terraform questions, which I managed to to pick up from the community, from different people who I talked to, and kind of aggregate it, and then we'll move to my favorite topic, which is Terraform modules. You will understand why it's my favorite. And then there will be a session of questions and answers. Preferably questions will come from you, answers maybe coming from me as well. Maybe some of you will be able to help each other. We'll see. And bar and coffee talk if there will be some people left by this time. Okay? So, yes, my name is Anton Babenko. I live in Norway, and I'm originally from Ukraine. So for the last 3 to 5 years, I was involved in Terraform and AWS quite actively. So I organize lots of events in Norway, and the next one, which is pretty big, is going to be Devops Days Oslo. And yeah, as you probably have heard about me before, most likely you saw my contributions on GitHub, because approximately 90% of what I do ended up as open source at one form or another. So some of my projects related to this talk include Terraform community modules, which started back in the days of about Terraform 0.6 maybe. And then I made Terraform AWS modules, which is a collection of verified Terraform AWS modules, and they are verified by community and by HashiCorp. And then just proof of concept I wanted to make a tool to simplify my own life so that modules can be generated and they are still used by community. So I made Terrapin, which is proof of concept. Then I made pre-commit Terraform to make my Terraform configurations clean and valid. So this seems to be used by some people. Last week I open source modules TF as AWS Lambda function to Terraform configuration code from visual diagrams, which I think is pretty cool, at least for people who like to draw things, but maybe not so cool if you like to have everything as code. So I try to fill this gap where you can draw something and get something practical and useful as code. And since I'm staying at Airbnb and it was hot outside, so I managed to write some Terraform best practices as I was preparing for this talk. So the last link is very much work in progress. It is the result of work of many people in the community who either wrote different blog posts, asked questions, answer questions, or send emails to me, or send emails to mailing list. Lots of different sources for this. But Terraform best practice, the way I publish it, is primarily my vision of what is going to work and why it's going to be good for you to use. It's totally opinionated. I want to, by publishing this, I want to get some attention from the people who can tell me clearly that, oh, this is bullshit, this is not going to work. And then we will discuss, okay? Not before. So that's why I publish it. So occasionally I tweet something. Again, all of my tweets are about Terraform or AWS, so that's what I do. And I also sometimes write different blog posts. So yeah, I like open source. So one big event which is going to happen in October is going to be HashiConf. First day of workshop, and then couple days of talks. As far as I remember, there will be about 400 people from around the globe, lots of people with similar problems as you are facing, lots of users and lots of experience back. So if you have possibility to go there, I would really recommend to go there. If you want to go there but ticket seems expensive, please come and talk to me. It will not be cheaper, but I can tell you something. So what is HashiCorp? I guess you had some thoughts about why HashiCorp and what kind of tools they have and what is all this about, right? So let me ask the question, who here knows what is HashiCorp as a company and what kind of tools they have? Like actually half of people, I guess you are actually using half of this, right? Again, so same amount of people know what is it and they use it. It's funny, but there are no logos. No, here is logo. I copied it. So, right. So on this slide we can see the whole application delivery life cycle, where it starts from the top, where developers write code, then they somehow test it, package, make infrastructure, deploy, and then connect all of these things together. Pretty traditional, I would say, application delivery life cycle. But what HashiCorp is doing is actually providing tools for all of this, where we are not going to talk about any of this tool except this one, Terraform. So I can say that this is Vagrant, this is Packer, and this is Nomad, and this is Console, and all of this is secured using Vault. So why to use Terraform? That's one of the biggest questions which people can think about. There are already a lot of tools, but why Terraform? Okay, initial statement for the Terraform was very easy. This is a tool which can write, plan, and create infrastructure as code. Nothing else, that's it. So you have this easy to understand file where you have declaration of resources like AWS S3 bucket, and then you want to output this bucket ID here. So then you run Terraform init to download some dependencies, and you see what is going to happen, which you then confirm as yes, I want to have this created, and then in the end you have this bucket ID here. So that's the whole, the core principle of infrastructure as code, where you define first, then you run some command, and you can reproduce it over and over. That's one of principle which infrastructure as code is for. But we may think that, okay, but there is CloudFormation, there is Google Cloud Deployment Manager, there is Azure Resource Manager. All of these are doing the same things. Right, that's a very good statement, because all of these are doing the same things for their own cloud providers. And it may be very hard or literally impossible to connect some of these resources and, let's say, mix and mesh different providers. So instead of using all of these three things, we can use just one thing. Okay, so we don't need to know AWS CloudFormation specific YAML, JSON, Magic, whatever. Google Cloud, YAML, Magic, Python, Jinja, and Azure, whatever they use, wrapped in JSON. So instead we write something in Terraform which is potentially easier. Right. Or what about other providers which are DNS, PagerDuty metrics, logs, New Relic metrics, G Suite accounts, Dropbox files? All of these are still infrastructure, and they still can be retrieved, updated, deleted. So wouldn't it be cool to actually use one tool to get access to all of these providers at once? So often the question which I hear is why on earth I should use anything else than a tool which is provided for me by my cloud provider. So most typical example is that people are familiar with CloudFormation and they don't want to look into anything else. That's typical situation, I would say, because AWS is not providing any support for Terraform, right? So you will not know about Terraform unless you really dive into documentation, into click from AWS side. So Terraform, just as some of you already read, I just want to highlight that it has easy syntax and it has native support for modules and remote states and few other things, and it's open source. So you really can see what's going to be developed, or you can even affect when certain feature will be implemented you can actually start writing code to implement this feature, or you can provide some feedback about different features. So that's the beauty of open source. And I'm actually glad that we are in the company whose statement was enterprise and open source. I thought we are on the wrong floor, but yeah, it's kind of cool that enterprise and open source. And the way how Terraform is doing is by building graph of all the resources and connection between them, so that back in the days, Terraform was faster than AWS CloudFormation for creation of similar amount of resources. Again, back in the day, and it's still the case, there are some features which are released in Terraform earlier than they become supported by CloudFormation. So that's the beauty of open source, that if there is something missing and this feature is already supported in SDK, then it's very strange that it's not in Terraform. There are certain limitations why not everything is in Terraform, but that's a pretty big discussion for later. So let's move on. So what is Terraform goal again? So we have a unified view of all resources in infrastructure, and it has coverage for a variety of infrastructure as code, platform as code, software as a service, whatever. And everything what we are describing in HCL is going to be talking just for API, just talking using API. So the only thing which is available can be supported by Terraform. Okay. So another thing which is I even underlined this word. It's not very typical for me. You see, most of my slides are on black background, but this word is really underlined. That's because I believe that this is a good candidate to be a universal tool. Universal tool, not just looking into resources which you create on your cloud provider right now, but as I said earlier, you have lots of different providers around. Being as an extreme example, you can think about this as that you, during onboarding process, you create a simple piece of HCL code where you describe what is first name, last name, which department, whether he has to get access to this AWS account, what his Gmail username should be, what kind of New Relic access he should get, whether he should be able to access Jira, and what kind of Datadog permission can this user have. Imagine doing all of this in one module or in one HCL file. Previously, you used to click lots of links and you have to remember all of usernames, passwords everywhere. But since all of these platforms are having an API already, it would be strange to not use it. And imagine that you can manage lifecycle of all of these resources using code. So there are lots of different solutions out there, and it's very hard to figure out which one is going to be relevant for your specific need or for your specific provider. So I just pick up 5 which are really used by literally everyone, or not everyone, but they are powerful enough to cover lots of needs for everyone. So the first one is Terraform Registry. Is a collection of public Terraform modules for common infrastructure blocks. So that's a place where I maintain Terraform AWS modules, and Terraform AWS modules are by far the most popular there. It has its own problems, like why it is so. It's not because AWS is used much more than everything else. It's just hard to find someone who is willing to maintain these things for the other providers. And also, if you have possibility to run Terraform plan, you will see some things which are going to be happening. But sometimes you want to put a little bit values which you are specifying are actually correct. For example, if you specify AMI ID, TF-lint will actually talk to AWS and will verify that this AMI ID actually exists and you actually have access to it before running Terraform code, which will fail because this AMI doesn't exist, for example. and a few other things. JSON.NET is going to be used not so much because Terraform 0.12 is coming and there are lots of solutions for this one. Right, so another one tool which is very interesting from my perspective is, because if we look into the whole Terraform scope, we have projects, we have open source Terraform, right, which is CLI, which you can download for free, you can run on your computer, on CI server, that's fine. You can do this for pretty long time. But if you are a huge bank with lots of money, with few developers, you can go and pay for enterprise version. Enterprise version requires a lot of money, so you have to find balance between having more developers or affording enterprise. So it's really expensive. So Atlantis is one of these tools which stays between open source, totally free, and enterprise, terribly expensive. So Atlantis is a way to run similar commands as you would do from your machine, but run it from central place. So you can go to this website and see a nice video which Luke, the maintainer of this project, made, and you can get a clue what is this about. But think about this as this is a centralized way of running your Terraform configuration, and don't let developers to have full access to it. It has still lots of challenges, lots of limitations, but it's on its way to success. Does anyone use this now or looked at it? No. Yeah. Yeah, so running it on Jenkins server is probably a old-fashioned way, because one thing which at least I believe into is that if there are things which you don't have to manage, you don't have to manage them, right? So this is exactly the use case. You have to have just Docker image which run this Atlantis server, which is available for GitHub to access, and that's it. So if you're interested to get a try this one, I open source Terraform AWS module for running Atlantis on AWS Fargate. Yeah, so this means that you don't have to manage infrastructure for this one. Okay, another one, TerraGrant. Does anyone use TerraGrant? Cool, just one, come on. It's one of the best tools out there. It exists for at least a couple of years. Okay, so a long time ago you used TerraGrant, and you know what? Since that time they didn't have logo. So maybe somebody can come up with ideas. Because you see, this one has logo and this one doesn't. So I open issue and people should participate and come up with ideas, but no one contributed. So what TerraGrant is doing, think about this as, you can read this sentence, but I will try to say it my words, is that over some time you was writing Terraform files. You describe resources, variables, outputs, and you do this pretty repetitive process for different stacks over and over. Then you figure out that, oh, there are some repetition between company A where I worked and company B where I work now. So it's probably a good idea to run it, to extract it as a module and copy-paste it. That's an idea which I had when I come up with Terraform modules back in the days. So that I work as contractor, and why should I write the same code if I can open source and tell the company that, hey, I maintain this stuff, so you should hire me and I will continue maintaining this. So this worked pretty well. But TerraGrant saved me even further, so that when I try to combine these modules, these infrastructure modules or resource module, to satisfy needs of specific customer, TerraGrant does heavy lifting for me. So TerraGrant expect me, just give me URL where this module is and what keys and values this module expects. And the rest of copy-pasting, TerraGrant does for itself. So at the end, TerraGrant allows to have much fewer code to maintain and very easy to explain to customers and to teams I work with what they have to change in order for their projects to be up and running. They don't have to know any details about how Terraform is working, how resources are configured. That's totally hidden for them. They can definitely look into source code and figure out what's going on, but the idea is that you hide whatever is not necessary for them to know. And this is where TerraGrant is pretty good. Hopefully bottom sentence says similar. Yeah. Okay, another question which is pretty often from the community is after they read some documentation, they see on some pages there are some scary notes that, oh, make sure that you don't put your safety information here because it will be persisted on state files, so maybe you should do something else. And over some time, I discovered that there are at least these 6 ways if you cannot tolerate existence of secrets inside your state file. So actually there are 6 ways which I described here, but in fact there are even more ways to satisfy this, because you can always invoke AWS Lambda to generalize it by, if possible, you can use PGP with Keybase to be able to manage your IAM users and access keys. So this way it will be encrypted and it will be stored inside state file, but it will be possible to decrypt only for the user of this keybase which was used to encrypt, which is pretty good. So everyone can get the state file, but it's encrypted. A very common solution for relational database servers is that you set some dummy password, which is, yes, it will be persisted in TF state file, but you change it right after database was created. It has some drawbacks because there still be time and still be situation where you create something but didn't change password yet, but it's possible to chain this execution so that it will be no problems. One of the recent addition was AWS Secret Manager Service, which allows you to manage secrets and get them by different AWS EC2 instances, for example, and it can rotate them for you. The only downside is that if you have a lot of secrets, it will be expensive. As far as I remember, it's like $1 or about $1 per secret or something like this, which is a lot. If you have a lot of them, you can calculate. I mean, you can multiply. And oh, good. I forgot one more thing here. So actually, number 7 is that there are certain utilities which people come up over time to encrypt values in state file. One of these utility is called TerraHelp by Nikki from OpenCredo, and she wrote this tool pretty long time ago, about a couple years ago, when there was an urgent need to make sure that even if you get access to your state file and it contains some secret stuff, the state file is encrypted, as far as I remember, with PGP as well. And quite recently, like 1 year ago, there was addition to make it possible to encrypt with secrets with Vault or something like this. So Vault is involved. So in order to use TerraHelp, you now have to manage Vault as well, which is probably a good idea if you already have Vault, but not so good for the majority of cases. So other options which people tend to implement right out of the box is just make sure that your remote state location is restricted by S3 bucket policy or using KMS key to encrypt at rest. That's usually enough. Yeah. Yeah, so the question was whether there is a way to intercept with Terraform behavior and add hook which is going to be executed once Terraform wants to push to state file, right? as far as I understand, there is no way, and there will be no way like this in the future, because Terraform should not be so smart in these cases. So what people are willing to do, or what people are doing right now, is that they wrap a lot of things around Terraform. So that's like one of the problem with Terraform. If you have problem with anything, you tend to make the easiest solution first, right? And what you know? Oh, I know Bash. So let's make a wrapper which will encrypt something, which will do something, which will push something. So then you have your own bicycle. Like 2-3 years ago, it was a good, I think, tradition for any company in the world to make their own wrapper for Terraform, and this was exactly use case. So if we look into how you can intercept with Terraform behavior from the module, there is no way. So if you need to do something after code is executed, the best example is to use either outputs or null provider to execute some code after your infrastructure has been created. So null resource you can use to call your shell script after something has been done. But natively there is no support for Terraform. And think about this also, as Terraform should be universal. I believe that not everybody is using AWS here. So, and it's hard to figure out whether we have to rely on KMS or not. So there are a lot of companies who are using Terraform, and they make tools just for their specific usage of Terraform. So some create tools specifically for Terraform and the AWS. Some create the same for Google. So that's probably answering your question, as you just said, that you can have null resource which is going to be triggered after something has been created. So after this is created, then there will be this AWS CLI command executed with this web ACL. So if you have this resource block in your code, then it will be invoked after everything is created. So that's exactly the way how you can change password on relational database server. So Terraform modules. So we finished the kind of the easiest part, where we talked about what we talked about. We talked about tools. We talked about why to use Terraform, and it was pretty straightforward, right? So I'd like to talk about Terraform modules, and there are certain things which are different in Terraform modules. So I made this fancy diagram during weekends because I want to actually illustrate how you can think about Terraform configuration codes in a pretty effective way. So that on the top of this you have infrastructure composition, which is, if we look from the bottom, then we have, this is the place where you define what kind of infrastructure and resource modules you want to invoke. In this diagram you invoke in one infrastructure module, right? And you can also specify which region I'm going to be working with, which environment is it, which version of my modules I need to invoke. So that's like your highest level. That's where TerraGrant is awesome. If we look deeper, then we see that there is infrastructure module which is invoking some data sources, and which is also invoking some resource modules to create something small. As you can guess by names, that resource modules are just creating resources, and they do this in very flexible way. So they don't have almost any limitations, any restrictions. The most suitable restriction which you can think about resource module is to help user to provide correct inputs. For example, if some resource should not contain dash at the end, then you simply have to cut it. That's the maximum what resource module should be doing. And it has no relation to anything else. It's very isolated. I'm talking about this resource module. And infrastructure module is often something in between, where you actually implementing things which either Terraform is not able to provide to you right now, or you have to enforce some company-wide standards on naming or tagging. That's exactly where you have to do this. So your infrastructure module, think about this, that your infrastructure module consists of a bunch of resources. And instead of dealing with resources one by one and try to combine them on infrastructure level, you put them into a little bit bigger group, which is called resource module. So infrastructure module is also a good place to use a tool like JSONnet to generate some JSON structure. So for those who don't know, Terraform can be used with HCL or with JSON. It's way here on this URL, which is again open source. So if you find anything what you disagree or you think should be improved or simply delete or simply totally worthless, please open pull request and we can discuss it there. Maybe I will agree to you. Okay, so over some time working with Terraform modules, I start to figure out what is actually good module or bad module and how they're different. I maintain Terraform AWS modules which were downloaded more than 1.5 million of times. People are using them in pretty different combinations, and I think one of the reasons why people are using them is because it's really feature rich, not because it's clean code. No, sometimes it's not clean code, and that's okay. I mean, as long as it does what it should be doing, it's okay, but it's really feature rich. If you say that you want to make a VPC, believe me, there are 52 input arguments which you can specify for VPC. This includes crazy combination, crazy amount of subnets, and this includes even type of subnets which is not used anywhere. Like literally, I used to dive into RFC to figure out that, oh my God, this type of subnet really exists. I mean, it's not just public and private. It's called intranet. It's where you have private subnet but without access to the intranet. It's like private subnet but without NAT gateway, which is very popular demand for Lambda functions, for example. And more of this is exactly the reason why these modules are used. They have same defaults, means that most likely if you just invoke this module, you will get nothing, which means you don't have to disable a lot of things to make things going. So if you specify that you need to create security group and don't specify anything, there will be no security group because you didn't specify it. So there will be no crazy errors which are pretty tricky in Terraform because they often look like as encryptic magic, which is error in this line, and you sit and guess why, where, if you inherit it many times. Yeah. Tests is probably one of the strangest parts. I don't believe in infrastructure modules testing at all, because I think that there are so many variants, so many combinations. As I said, VPC module has 52 input arguments. So what kind of 52 factorial I should make, or what kind of test I should introduce? I mean, I'm open to some discussion about that, but I don't believe that tests should be very generic and will try to cover a lot of things. I've been into several discussions where people want to add tests simply because they have tests for their application. Fine, you can test it once you create something, or you can test your real infrastructure once it was created, but it's not job of the infrastructure or resource module to do that. Because again, resource module is totally stupid. It accepts whatever you tell to it and it will make it. If you specify strange values, okay, it will make it, but you just specify it. So I really am not sure what to do with tests. So far, only one module which I maintain has tests, simply because guy who said that he will not use this module without tests. And I said, okay, you can add it. So since that time, I didn't change that test. So I'm sure that it's broken. but it's okay. I mean, right now the situation with testing in the Terraform scope is not so good and is not so changing, I would say. Does anyone know what is TerraTest? Right. So, what's your experience with this one? Can you tell? So TerraTest, just so that. Yeah. Right. So the thing is that I don't know if I should repeat question or is it recorded? No. Okay. So yeah, I just asked what is TerraTest. So the TerraTest is a way of writing infrastructure tests in Golang, which you run on real infrastructure. Something like this. So where most people are lost in writing Go code. Believe me, I was in a situation where it was hard to explain to people that, hey, this is Terraform. It's not so hard to learn it. And they say, no, it's very hard. So, okay, then we use TerraGrant. Are you happy with this structure? Yes, I'm happy. Now, if I go to them and say, hey, guys, you're a Java developer, no problem. You have to write this Go code, which looks very different from what I just convinced you, that Terraform is easier because it's HCL. And now I say, hey guys, you have to write this Go code. So I lost another half of audience. Another problem, which is more problematic, I would say, is what you're actually trying to cover is much more complicated than it may seem. Because what TerraTest is doing is going to your real infrastructure, creating this resource is present, that this resource is configured in correct way. For me, it seems a little bit it's like trust no one. I mean, I trust AWS that it returns proper exit code to Terraform, and I trust TS state file. What possibly can go wrong? So it's a big topic, and I'm looking forward to hear some discussion at HashiConf. I hope there will be some announcements. Examples in modules is one of these the most how to say, the strangest part of Terraform modules for me is that people don't respect examples. Examples were written for the reason to be absolutely working the way it is described in README MD, and not more, not less. All tests without any exceptions, or all examples, are executing something real only if you run Terraform init, Terraform plan, Terraform apply. Only these commands. You will never have to specify any extra details like, by the way, use this region, or by the way, I use this specific feature. All of this is using data source to find your VPC, your default security group, and so on. So you don't have to be very creative and think about tests like, oh yeah, thanks for writing this test, but I know that this is boring, so I will open an issue when I will ask you exactly the same question. So it happens quite often when I have to answer somebody and say, hey, by the way, you have to check example because that's the place, that's like contract between this code and that it works. That's how I verify most of code right now, is that I go to examples directory, me or some automation system, and just execute example, usually with name complete. Complete is like keyword, which I use internally, which means it will create something in very complicated setup, which most likely will catch your error. So test and example, they're very close here. But again, examples are real tests. So I test, again, absolutely real things. I test that, yes, you have default security group because it's always there. I guess you have VPC. I guess you have this set of resources. And I just pass them into the module which I'm testing. Documentation is pretty funny thing. When I talk to people from US and say to them, hey guys, you're English speaker, I'm not. why it's so hard for you to write good documentation or any documentation. They always say like, yeah, but nobody will read it. But believe me or not, any documentation is better than no documentation. So that's how I started writing README into modules which I maintain. It's just by writing whatever I feel may be applicable, and then somehow group it around, and then see people actually contribute it and add another paragraph, another chapter, and sometimes README gets big and big, but it's better than nothing. If there are thousands of grammar mistakes, no problem. I mean, it's probably my problem, but sometimes I fix them, or other people, sometimes even English speaker help me and send an email and say, hey, you know, you made so many mistakes, this is correct one. So I just copy paste, but I think that any documentation is better. I can write much better in Russian, for example, but nobody would read it. So yeah. Many other things which are outside of this scope is like how to guarantee that your module is actually doing what you expect it to do. Like if I say that this is VPC module, do you need IAM access credentials? Do you need to have a chance to create users, or do you need to destroy instances? So there are, if you are using any module right now, you trust 100% to this module creator. You have no control, like that this module will not suddenly be compromised and new feature will be added so that everything is broken. Same with lifecycle readiness. I was beaten with this multiple times. Pretty funny situations happen sometimes is when I change something, like I changed some name of resource, let's say now, and then I figure out, oh, I made some mistake. So I changed slightly different things, and I pushed new version. And then during this half hour, one guy managed to download this module, create something with this, and then he ran it again, and it destroyed what he just created. So the existence of this version was like 1 hour maximum, and he managed to find that this bug was introduced, or this. So he used during this 1 hour, and he destroyed half of his infrastructure, whatever happened, and he opened an issue. So that's one of the reasons why you really have to specify version. I mean, yes, versioning is very hard. Versioning in general with modules is pain in the ass, like it's dependency hell, but in HCL. One of the idea with versioning is that you just have to specify as precise as you can. Most of modules which at least I saw in public, they are not following semantic versioning entirely, because otherwise, if we would follow semantic versioning, it would be like Mozilla Firefox version 57.10.25. Instead, we don't increase major versions so much. We increase minor and patch. So that's why some modules have like 1, means that it has been created somehow, sometime. And when it will be absolutely non-working with previous version, then it will be 2. But in general, we just increase minor version, and it's okay. I still have difficulties with generating changelog. So if you have some good ideas how to generate changelog in a effortless way without asking people, but rather use some tooling around it, I would really appreciate it. Because right now, I have actually some people from, I think from Madrid, open issue a long time ago that, hey, was it you? Yeah. No, cool. Yeah, so, you see, small world. So, yeah, so making changelog helpful is very complicated work for me to do. So in general, and not just for me, but I can say quite honestly that modules which I maintain, they're in much better shape than majority of other modules. Simply because it's not just shameless plug, but that's the fact that I spent time thinking about all of these aspects like full time. I'm not get paid by HashiCorp to do this, but it's just fun for me, and people are using it, so I fix it, and changelog is outside of my scope for now. So that's it Terraform AWS modules, they are used by, they contributed more than hundreds of people, including you. All kind of documentation, all kind of opening issues or discussing with other people, all of this helps. Especially when I was on vacation, I made a pretty good experiment myself. I wanted to verify whether open source community is sustainable, so I went on vacation for 45 days without any single commit, any single merge. And the only thing which I noted was that a lot of people forked several modules, and they actually continue developing in their fork. Why? So what I normally do is like what I did before that, is that I monitor a network of forks, and if I see something cool, I submit a pull request from his branch into my branch. Why not? So this time I also do similar things, especially if people made more or less big progress. If it's just small thing, of course I'm not gonna to take it, but I usually ask people to contribute back, because that's how open source work, at least I think. And more than 100 developers are thinking the same. So far we have a bunch of I would say it's limited amount of modules. Why it's limited is because this process is not scaling right now. There is one human writing all of this, pushing all of this, testing all of this, or some of this, and this process is very, very kind of hard to scale. That's why I will look into details like how to increase this amount, because the amount of resources which Terraform can manage right now is more than a couple thousands of resources, and we can have here like 1, 2, 3, 4, 10 resources. Maybe not 10, maybe 50 resources. That's not enough. So what about all these crazy services which are happening like in AWS every time? With Google it's quite different. Google has its own magic, which is called magic modules. So, oh my god, another, who knows what is it? One. Cool. He actually didn't know this before I tell him. So, did anyone see this one before? Cool. So more people than usually. So this is product by Cloudcraft, and it's used by Cloud Architect to design and to draw all of these things, to move boxes, to connect different components together, to put some values like what type of instance, what type of load balancer is it, and so on. So they really like these things. They like to move different boxes and so on. As I showed earlier, I'm writing Terraform best practices guide now, where I'm actually thinking what are the best ways to generate this specific infrastructure as Terraform, which is very wide question. If we ask now, I will guess there will be at least 20 different solutions. Like somebody will say, oh, this is okay to describe it in all resources in one file. Fine. Somebody may say, oh, let's think about this availability zone as one file and this is another file, and so on. So you get the point. There will be lots of different combinations. Most straightforward one, which is actually happening in real life, is thinking about this as layer, so that you have layer called Elastic Load Balancer, then you have a layer called Autoscaling Group, then you have another layer which is Elastic Load Balancer, another Autoscaling Group, and RDS. So you think about this as layer. The way you look at this is exactly as layer. So once user hits something, he hits this one, he hits this Autoscaling Group, another load balancer, and so on. So that's exactly the approach which that's kind of features of Cloudcraft. Calculate the budget. A lot of people really like to know how much they're going to spend. And import live infrastructure is also to go in AWS console, you click like cowboy everywhere, you created all of these bunch things, and then you think like, oh my god, there is Devops, there is infrastructure as code, what to do now? So you import everything here. Wouldn't it be cool to actually get from this Cloudcraft diagram as we saw now into opinionated structure of Terraform, the way we just talked about it, as layers. Because layers, again, is one of the most powerful approach which people are using. And then from Terraform we can execute it into AWS and get this infrastructure created. And then again, we can use the import feature from Cloudcraft to update some things here. That's like real ideal world. So you have console, you have diagram, you have infrastructure as code, and you have modules TF. So this is my project which I released last week. Again, it's open source, 100% free, and it's infrastructure as code generator from various sources. I started with Cloudcraft simply because this is awesome project and they pay money, but I believe that anything what you can use to describe your infrastructure, think about this as text file, or it can be another drawing tool, or it can be XML file which is just your proprietary Balsamiq or draw.io is using. Anything like that. All of this can be generated as Terraform code. So you have Cloudcraft, you have a bunch of already existing Terraform AWS modules which are literally building block, and you have Terraform, which is the tool which actually does the infrastructure as code. So right now it is deployed here, and if you add this question mark beta, you can see how it's working. And the idea is that right now it suits best for bootstrapping. So it's not so smart as majority of you guys, or actually as any of you, as all of you. I don't know how to say it in English, but this tool is absolutely stupid. This tool is just trying its best to find resources it knows about, figure out connection between all of these tools, all of these components, and it tries to enforce Terraform best practices by putting this code into proper places. And in my experience, it suits very best for bootstrapping because you don't have to create, like, I don't know, for this specific example, you don't have to create about maybe 10 kilobytes of code, maybe more. So I think it's pretty good saving, and it's open source, of course. Yeah, if you want to sponsor our sticker, come on, good, then contact me. I have a bunch of different stickers with me. So what's next? As I said earlier, involve more people and code generators. It's very important to actually use code generators, because involving people is very hard. Really, it's so hard that over I would say 3 years working with Terraform AWS modules, I had maybe 5 guys in total who contacted me and say, hey, we want to contribute this module, and they were flexible enough to adjust their preferences, their way of thinking, to be compatible with the rest of things. All other people wanted just, hey, this is my module, which is like no documentation, no example, nothing, just throw it to me and then I have to maintain it. That's not the way how I want to work. So I made this Terrapin thing, and now I made this modules TF. Terrapin is proof of concept in Python, Jinja, which is very hard to convince. Like, again, guys, you like HCL, but I want you to write Jinja template, which smells. So I will probably rewrite it to HCL. And a pretty funny thing which is happening right now, I guess not everyone is using Terraform on big scale on, let's say, for 2-3 years with hundreds of developers. But that's exactly the use case which I see. Terraform is one of these tools which is very easy to get started. And then you sell to different teams, and they are hooked up and say, yeah, I can write my code, I can push something, you see I have infrastructure there. And then over some time you have lots of snowflakes between team, projects. Within one organization you can have like no structure. Again, that's one of the reasons why I want to enforce best practices and want to hear what other people are thinking, because Terraform refactoring is one of these tools, or one of these problems, which is already a real challenge for companies who were creating lots of these things, what they should do now when they have everything written in so different style. So just for my own experiments, I made Terrible, which is Terraform plus Ansible, of course. So I use Ansible to orchestrate Terraform to do some refactoring. Yeah, it looks exactly terrible. And I use makefile, so that make terrible plan or make terrible apply. Yeah, so I use it for internal refactoring. For example, when I had about 50 different projects which were structured pretty differently, I want to make sure that everyone was using the latest version of our internal infrastructure module, which is let's say 1.1.1. And I want to search every code base and update it gracefully. Gracefully means that I do recursive operation in each of these folders. Like I find this project, okay, they're using not latest version, I run plan, and then I run apply, and then I go to another project, and so on. So that's exactly the idea of Terrible. Ansible is not good fit for that one at all. So I'm really glad with the name most of all. So dependency hell problem with modules. Who has been trying to figure out which version to specify in module, in Terraform, and in provider? So right now you have to do this in 3 different places. And you have provider configuration where you specify specific version of provider. You have Terraform where you specify again something. And then you have module which is specifying just module version. So right now this magic is very hard to predict what's going to happen, especially if people are making very bad mistakes by putting provider configuration into the module itself, which means that you cannot override it and you cannot do anything with it. So that's really important use case, because I once made this mistake myself in I think in security group module, where a new feature was introduced in specific version of AWS provider. So I thought, what possibly can go wrong if I just add provider configuration into main TF on this security group module? And I didn't do anything else than just specifying provider and version more than specific number, I don't remember now. And I push it. Again, it took less than half hour for someone to discover that it breaks everything for him, because he is actually configuring provider sections on the very high level, on the composition level, which is correct. But I was hoping that it will merge this provider configuration somehow and will make sure that provider is used properly. It was my just bad guess, I would say. So since that time, I kind of got another confirmation that yes, it's a bad idea to put it anywhere else than composition, and I learned it during half hour. That's the beauty of maintaining something in the public. You don't test on your computer, you test it on someone else. And almost always I write that, hey, by the way, it's better if you don't use master branch of this repository, but stick to specific version, because you never know what kind of guy I am. Maybe I will change something tomorrow, so we'll break again something for you. When people take this too seriously, then they fork this to their own repository and maintain them like internally inside their organization, which is fine if they want. Okay, so get acknowledgement and support from AWS. This what's next? Yeah, maybe eventually after 3 years, and I don't know, tons of effort talking to AWS, they will do this. But so far there was no support from AWS. So, and your ideas? I don't know what is next. Do you have any ideas? Okay. So what is your Terraform question and problem? So I'm kind of done with all these slides, mostly. So I talked about different things, like how it works, how modules exist, why they exist this way. And I hope you have other questions which are outside of this, so we can just shout. Yeah.
Is there any form for making Terraform to destroy any resource in your system that Terraform hasn't done? I mean, we tried using Terraform destroy, but it has to have the Terraform state for destroying the resources, but we don't have it. Is there any form?
I'm not sure if I understand.
You don't use terraforming to get data from the cloud. I read your account and then.
No, but the question was what to do if Terraform does not support it at all.
We did some resources without using Terraform, and we want to know if there is a form for destroying that resources using Terraform. For example, Terraform has the Terraform destroy instruction for destroying some elements, but for destroying that elements you have to have the Terraform state.
Yeah, so that's right. So Terraform will not do anything with things which it doesn't know about. So there are multiple ways how you can instruct it to do, either by putting whatever you want into state file using terraforming, or manually edit this file and push it. But most likely, if you are dealing with a system which has some sort of API already, right? So what are you talking about, AWS, or what kind of provider are you talking about, where these resources exist?
Because we did them, but without using Terraform. It's like.
Do you use AWS or?
I don't
which provider you use?
Yes, Amazon. Excuse me, Azure. There are Azure.
No. It should be easier to answer. So the thing is that if there is like thinking about AWS, you have possibility to click in console, then import something and write configuration code for it, and run plan, and then it will tell that nothing to do. So what you have to do now is that you have to do two things. First is write state file, anyhow, most likely manually, because there is, I don't know, any terraforming which can work with Azure. Terraforming is Ruby gem, which talks to AWS API, get information, and generate code for you in state file. So what you need to do, you have to write TF or HCL code and put it into your state file. There are some tricks about what you should be doing with state file, because Terraform is trying to do some smart things, like it will always try to guarantee that you are changing latest state file. So the trick there is to change serial field and increase it, and then push it. So what you do is that first you write Terraform state pull command. It will pull state file. This state file will be empty. So you will put your JSON magic for your resources for Azure there. Okay. So once you put it there, then you write your Terraform code which mimics exactly these resources. So literally write in resource Azure blah 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 and create with bunch of parameters. So once you have this, then you have state file and resources. Then you write Terraform state push command, and you push this command to make sure that Terraform now use this version, and will incrementally change it after that. This was very popular request back in the days before import command exists. So I think almost 3 years ago I was looking into like how to fulfill features of Terraform which are not there. For example, what to do if resource type is not there, or what to do if feature is missing in specific resource, like how to fulfill. But with AWS it's quite easy. You use CloudFormation or you use AWS CLI, with Azure, I guess you have to use something similar. So you can invoke your, inside your process, you can invoke your Azure CLI, which will do similar things by calling AZ CLI. But yeah, it's pretty advanced and it will fail miserably many times. Any other questions?
Yeah, I have one.
Thank you. Okay, you said that you're not particularly fond of testing in models, but I'd like to know best practice for testing a change in a code before, let's say, deploying into production. I've read that some people have, let's say, 3 or 2 environments, maybe a dev environment, a pre or integration environment, and the production. But I don't know, maybe even that I would still feel risky before applying. I mean, hitting enter and hey, go to production. So, what would be your approach for a safe deploy?
Yeah. So let's see. This, yeah, probably this one. So I was solving exactly this problem multiple times, and over time I figured out that the best thing which works the easiest way is just to establish so-called pipeline. It's not pipeline in the way that you change something and then you promote artifacts, but since everything is versioned, your infrastructure module is versioned. So you have your dev stack with your version, which is right now, and you have your production infrastructure, which is referring to exactly the same module but with another version. So what you have is that you have a bunch of your configuration separated by different folders where you have dev, stage, and prod, and by just inspecting these files, again, files will be always in known location and it will contain which version of the module you are trying to invoke. So you can always see that there was version 1.1.1 and now you're changing 2.2.2, and that's exactly what your change is. So by talking in practice, we had environments, so several AWS accounts and dev, stage, and prod. So in dev, failures were quite often. So we push something and then break apart, and then we fix something iteratively. And when we were pretty happy, then we pushed the same version which we just deployed to staging. So then we saw that, okay, now it works in staging. In 100% of cases, we were confident enough that this will work in staging and in production, because we just made lots of errors in dev, made almost no errors in staging, and most likely, literally, it was no problem with this chain. So sometimes we had a lot of resources which were not needed, and sometimes we had possibility, or we had situation where resource was like recreated many times than we wanted, but we had versioned artifact, so-called, which we promoted. Yeah.
Okay, with this approach, I think maybe you assume that there won't be any manual configuration, let's say, in production. For example, there's some need for an emergency acting. I don't know, something breaks in production, and the guy on call have to fix it somehow. I take the scenario where he doesn't remember, let's say, to use to change the Terraform files, the Terraform files, and then he just goes, or she just goes and fix it manually. And then what happens with the next Terraform apply? Well, I guess there will be a Terraform plan, but maybe, who knows, there's a chance that the plan, let's say, hey, everything will be fine, apply.
Yeah, absolutely, this situation will happen, and there is no solution for that, right?
All right.
Because what else you can do against cowboy who can do whatever he wants, right? So this can happen even worse when somebody created resource which Terraform doesn't know about. So, for example, for some hotfix, somebody created new SQS queue, with very specific name, and then you don't have it in development or in staging, but you have it in production. So then you will have. So definitely there will be situations where Terraform cannot help you. What I think is kind of missing with the whole community right now is that there are certain incentives to make process of hot fixing easier for them to fix it properly. So what can be better for this guy who was on call to just fix it a little bit, maybe longer, but properly, or make it as a routine to, like, sometimes we had it as a routine where we had like as a last step before going to bed, you just check that did I log all of my steps, yes or no, and then you can, oh yeah, I forgot to push it to this main TF file somewhere.
Okay, thank you. That's a really nice advice.
This is common problem for a lot of situations where people can change something, and I think the best way would be to just give them tools to be able to break literally everything in dev. So we had like, that's one of example. In one company I was introducing spot instances exactly this way. As in dev environment we were using spot instances, and developers were trying to figure out why their artifacts were always lost. And then they figure out that, oh yeah, they actually don't have to change them, they have to use Packer and build it. So this was, and they were actually saving money with spot instances. Sometimes people were angry, but price was on the very, very low level, so it was killing them quite often.
So when do you decide to split? Where's the split between an infrastructure model and a resource module? Like in, for example, AWS?
Yeah, so that's always tricky to answer in very generic terms. I like to think about this like one of indicators when it's a good idea to think about some separation of resource module. Maybe it's a whole infrastructure module now. Is the resource module is actually easy. Is you always take just one, maximum two things, like security group and security group rule, or one security group and infinite amount of rules. That's one resource module. That's fine. But infrastructure module is usually whatever describe your specific situation, what you have in the company. Let's say if it is stateful server or stateful, let's say Jenkins server, just for fun, to make fun of Jenkins. So you have stateful Jenkins infrastructure module, which consists of what it has, probably some auto-scaling group, launch configuration, bunch of security groups, elastic EBS volumes, and all of this is very hard to combine using resource modules like right now, because there are limitations of resource modules, dependencies between them, which is known issue, which will be fixed later. But the whole idea is that you have common infrastructure component, which is called Jenkins stateful server, which in this case doesn't matter how many resources will be there, but the point is that it's one thing which is solving your task. And again, inside of this module, you may use all of resource modules which are out there already. Let's say to create security group without knowing in details, or to create some other resources. So infrastructure module usually happens pretty late, I would say. Any other questions? I guess there should be some questions from this part of the room, at least. I feel it. Or maybe from this one. Okay. Does anybody know what is cookie cutter? It's a cool project. Yeah? Yeah. Yeah, so cookie cutter, what is it? It is Python pip library, which gets bunch of templates and it returns bunch of files generated from these templates. So you literally have file system as templating. So you can use double curly brackets and then some variables inside of it as file name or inside content of file name. So
using templates, so for example, templating your user data, because I'm doing that, for example, templating your user data to put, for example, export variable into an so templating your user data, yeah, to basically get an export variable, system variable with your environment, production, staging, wherever.
yeah, so this is not the use case for cookie cutter.
Yeah,
Cookie cutter is very helpful if you need to use variables inside file name. So let's say you create a file which is named by user. So this means that you create thousands of files with similar content. How can you create thousands of files dynamically based on input value? So right now cookie cutter is very powerful just for file generation. So what I use it for is to generate Terraform templates from these visual diagrams. It's because I know that there will be this layer and I know what is name of this layer, and I know that in this layer there will be files called main TF, variable TF, and output TF, but at least name of the folder, that's where I use cookie cutter for. You can look into code for this generator and
yeah, I took a picture, so yeah, we'll have a look.
Good.
Definitely.
But more frequent solution is JSON.NET. Does anyone use JSON.NET? You're lucky, because JSON.NET works with JSON, and yes, so you can generate JSON files using templating language. So you pass some JSON data and you get a bunch of similar JSON structures joined together. So this is particularly helpful because list does not have or list keeps orders as key. This means that if you have user 1, user, this means that the whole list after user 2 will have to be recreated. Yeah, and this is particularly unacceptable when you're working with things which are stateful like AWS access keys. You cannot tell that when employee with name, which is somewhere in the middle, leaves, that everyone who goes after him will get new access key now. This doesn't work. But yeah, JSON.NET can help you. In 0.12 this will be changed, so list will not have number inside, will not have. So this will be a problem with JSON.NET, and you don't need JSON.NET anymore. But
another question: can you use VPC pairing with Terraform? I mean, just.
Yes, we are using it.
Okay, because I never use it and I have to use it now, and I say, okay, this guy might know.
Yeah, so the thing with VPC pairing, I can just answer from this diagram. So think about this as infrastructure composition is where you define whatever you have at the top. You have, I don't know if it's possible to do now with inter-region pairing, but pretend that you have different providers, different different AWS provider. No, you have yes, region. So when you have VPC pairing, you have infrastructure module called VPC pairing, and you can specify who is it. Is it acceptor or is it requester? So when you specify, then you have two infrastructure modules next to each other, and the point is that you can, if they belong to different accounts, then you can override provider configuration on the composition layer for them, because sometimes it's pretty sensitive information, that one is owned by mega cool organization, boss who doesn't allow to do anything, so that's why his super secret credentials will have to be used in order to accept your request. So provider configuration happens on the infrastructure composition layer on the very top, but infrastructure module, which does the whole VPC peering, AWS VPC peering resource and acceptor, is happening here. Similar situation is happening, like one of practices is when you manage Route 53 zones. Is that zone by itself is pretty sensitive thing, right? And if you have a project or organization domain where you cannot allow everyone to have access to be able to do whatever they want with Route 53 zones. So one of solution which I saw people doing was to just delegate either subdomain or give them a way to discover zone ID from the infrastructure module. So the infrastructure module will just know that, hey, I should create a record inside this zone ID, and it will just use AWS Route 53 zone to discover it and use it inside the module. Yep.
Hi. Thanks a lot for your presentation. I have just not a question, but just an experience. It was about talking about the opinionated tools. I understand you know. Sorry. I don't know. You know the tool COPS with a K that generates Kubernetes
sure.
deployment on AWS. So they decide to when I tried to use it, it worked perfectly, actually against AWS, no problem. But they also have a export to Terraform module, and in my deployment it didn't work. So the idea is I have to invest time that I didn't have to understand what the Terraform code did. This is not. I understand you. If you have to debug Terraform files out from an output for a tool you don't know, you finally don't. In my case, I didn't try a lot to understand the generated files from COPS. I say, okay, just redeploy. It works. Okay, forget about it. So I don't know if maybe, I insist this is not a question. This is something like if every project, every opinionated project reinvent the wheel and they generate a Terraform files that you have to understand Terraform and you have to understand the tool. Maybe they won't. In my case, I didn't use Terraform to deploy my infrastructure. But just.
Yeah, I think first of all, thanks for pointing this situation with COPS. I didn't know about this possibility of export, but a long time ago I saw code which they generate, and it reminds me some obfuscator, which we used back in the days to save time in JavaScript, or to save space in JavaScript. So one of the things which so your question is pretty broad, or your statement is pretty broad. But I think when one situation which I totally understand, and you're expert in Terraform. At least you know what is it. Can you imagine how people are struggling when they get started with Terraform? So they say, their boss come to them and say, Kubernetes. They go to Kubernetes in Google. They download COPS. They run COPS. They run whatever they want. They're afraid to touch it after that because it just runs from first attempt. For me, it didn't work from first attempt, to be honest. But the situation with the whole Terraform modules generation, to my understanding, is that I mean, maybe that's just my experience, maybe that's my pain point, but I don't want people to write Terraform code, to be honest. I want to have tools which tell them very early that, hey, by the way, this code sucks because you are gonna to limit, or you are gonna to have hard times. Or when people think that they're going to be very smart right now because they just invented these things and they write something unmaintainable. It's very often when, so right now there are very few tools. One is tflint, which tells you later there will be a feature inside Terraform which will help you to make sure that you actually wrote what you expect. So there will be better error messages and better validation in time before you actually hit save and so on. So I don't think if we let COPS to generate Terraform, I mean, of course it will be obfuscated code. So I don't think there is magic solution. There is one feature, not feature, one related challenge is, imagine that you was using COPS and then they decided to change something, let's say in name instruction. So you run Terraform now, so your plan will tell that, hey, bunch of resources will have to be deleted and something will have to be created. That's not what you expect to do. So this means that Terraform should have much easier ways or much more features related to refactoring. So it has to have some sort of smart guess between, hey, I think this is actually a rename. Are you sure that this is, or that you want to destroy this resource and create exactly the same resource? So that's happening with refactoring, especially in open source. I saw this quite often. When I change something, somebody said, oh, you broke everything for me. I mean, that's life. So just to finalize this one, I think that the idea of people writing Terraform modules is dead without restricting them and without guidelines clearly. Otherwise, we'll just make another Ansible playbook. I mean, you have Ansible lint, which can guarantee that syntax is okay, number of spaces is okay, but logic inside of it is totally up to developer what to write there. So. Yep. And just another, yeah.
Hi. Maybe it's quite basic question, but I would like to know how will you face the problem of having three possible values in a conditional. When I'm doing an account and I'm going to provision one instance in AWS, and I'm trying to give it three possible values in its tags.
What kind of values are you talking?
Yeah,
is it three different, totally different values?
Yeah, depending on some variable I'm passing it by a pipeline or something like that.
Yeah, right. So currently, what is it? Conditional parameters or conditional arguments. So what that means is that you have resource block, and you can specify in count, as you say, var blah 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 or 1 minus blah blah blah. This is like gonna to work fine for two elements, right? And what you're gonna to what people are making is that they use local and declare whatever complex statement they want for 3, for 5, for 25 different variables there, and then use local inside of each. So local can be good short form of this, but I think actually I don't know if it's relevant for the most of people, but there are a lot of situations when you have to create resources with totally different configurations. Because, as an example, you specify if it's with EC2 instance, example can be that you have EC2 instance with network interfaces and without network interfaces. So you cannot mix them. So you cannot say network interfaces equal null. It will be possible in 0.12, but now you cannot do this. So this means that you have to copy paste the same code with network interface and without it, and maybe something else, and so on. And then play with count in each of these. Right? Count, equal, and then local, and your magic statement which you calculate somehow. The trick here is that when you do output for specific elements, then you have to use element from concat list, from concat, from 1, 2, 3 with stars in it, and then something else. So this means that you put your conditional concatenation of empty lists into one. So this means that there will be always at most one element. I described this in, I don't know, pretty good details, I think, in Terraform best practices. So also on Terraform best practices I am describing things like similar to what you just said. They are pretty unknown for the majority of people who don't work with generalization of things. So a lot of people are happy with just happy path, where they read documentation, copy example, put some basic arguments, get just attributes which they need, that's it. The funny thing will happen is that if you do, let's say, S3 bucket, which accepts approximately 15 attributes, and most of these are optional, but not in this combination and not in that combination, and so on. So that's one of example which I'm going to put on workshop. I have workshop with similar on Terraform best practices, and I don't want to write this code myself, so I want to have people. So we'll see. I made repositories on Terraform AWS modules. If workshop will be successful, we'll have S3 bucket created in bunch of combinations by these people. So we'll
Thank
see.
you.
Yeah.
Thank you very much. I think it was the last question. Thanks a lot for attendance. We have some pizzas. I think it's time to.
This is the last slide, or pre-last slide. So if you didn't know about Terraform, but you really want to get, I can just say how I learn new things. So I read README. This is the most popular page. No, really, I learned a lot about technologies just by following README. So README on Terraform and AWS Provider is the most popular website at all. So I visit it daily, talk to people who changed something there, why they change it, when are you going to change this because this will break that, and so on. So this is like 5 minutes a day, but stay on top of different things. So that's one thing. And I'm quite sure you didn't read this book, but you should read this one. I reviewed this one, but not this one. I was technical reviewer on this book, but it was not so successful as this one. So I recommend actually this one. Yeah, because it's a little bit, it gives more information than it's possible to give on Meetup. In particular, it covers some topic about how to actually cooperate with your developers in company or in your team, who should write this code, who should execute this code, and so on. And yeah, Evgeny writes very well, much better than I can speak. Yeah, I will definitely do this, yeah. But you can take photos of this as well.